Today I'll be presenting the custom pod autoscaler platform. This project was developed by me and Pedro Casas as part of phase 2 of the Analytical Performance Modeling and Design of Computing Systems class at York University. Just to contextualize a little bit, as part of this class we had to develop a project. This project was divided in two phases, phase 1 and phase 2. During phase 1, students were asked to deploy their own Kubernetes cluster, and inside of that Kubernetes cluster, students were asked to deploy a set of microservices. After deploying those microservices, we did a set of load testing activities inside of the cluster, and the reason for that is because we wanted to analyze how the cluster would horizontally scale based on those load testing activities, and that actually touches an important subject about Kubernetes, which is called the horizontal pod autoscaler, which is a technology that comes with Kubernetes that helps the scaling of pods. Just a quick refresher, a pod is just an abstraction that holds containers. It can be Docker containers or any sort of containers. And the idea here is as load testing is being done, those pods will reach a specific threshold and they will scale horizontally, meaning that they will clone themselves many times in order to be able to achieve a good SLA, or basically be able to respond to users' requests. So let's just do a quick refresher on the horizontal pod autoscaler, and then we're going to talk about the custom pod autoscaler. So the horizontal pod autoscaler, as mentioned before, is some technology that comes with Kubernetes, and its sole responsibility is to scale the number of pods in a replication controller, deployment, replica set, or stateful set. And it's generally based on the observed CPU utilization. So let's say a deployment in Kubernetes may have like 3 replicas or 2 replicas, or maybe let's just simplify and say a deployment has a single replica or a single pod. What the HPA will do, which is the horizontal pod autoscaler, is follow that pod and collect CPU utilization. More specifically, the HPA will actually talk to something called a metrics API, which is also a component from Kubernetes, and that component will collect the CPU utilization and provide that to the HPA controller. And that's the idea, like the horizontal pod autoscaler will be watching that metric, and if that metric achieves a specific threshold, the HPA will actually spawn a new pod with the same code as the one before, right? So it's just going to clone the pod for us, and because it's cloning the pod, it will be able to actually load balance all the requests between those pods. So that's the reason the HPA is extremely useful. And again, generally the HPA is used in its original form, which is just CPU utilization, but the Kubernetes folks also let you import your own custom metrics. And yeah, and that's pretty much what the HPA is. It's a controller that periodically adjusts the number of replicas. So let's keep moving forward. Here we have a simple diagram where the HPA is at the bottom. It's following a specific deployment, and based on the CPU data here, let's say as an example, it will actually send a scale operation to the cluster, to this specific deployment, and that this deployment may increase the number of pods or decrease the number of pods. Also, it's very important to point out that the HPA works per deployment, meaning that for each deployment in a Kubernetes cluster, we have an HPA associated to it. And that strategy will be the same one used by the CPA, which is the custom pod autoscaler. So let's move forward. Here are some snapshots from phase 1 of the class. Here we have a deployment list. The deployment list basically contains all the microservices deployments we've done in our cluster. And here we have some interesting commands. So kubectl autoscale deployment, and then we're specifying the CPU percentage, min and max. So basically with this command here, we can specify a deployment. So let's say the email service is a deployment, and we can specify a specific threshold, which in this case is a CPU threshold, is a CPU, because we're using the CPU metric. In this case, it's 50%. And here we specify the minimum and the maximum number of pods that we want the autoscaler to scale to, right? So maybe our CPU utilization is close to 0, and we're going to have 1 pod, but let's say the CPU utilization is going through the roof. We're having a bunch of requests on the service. Then we may reach at max 10 pods, right? Finally, we have also commands that were done in the previous lab in order to delete HPA. And again, HPA is associated to a deployment. So for each deployment, we're going to have an HPA pod that is associated to it. So in order to delete it, you can just do kubectl delete HPA and then the name of your deployment, and you're good to go. So talking a little bit more about horizontal pod autoscalers, they run the controller that basically looks for scaling, runs periodically every 15 seconds by default. That's also configurable. There's a flag called horizontal pod autoscaler sync period where you can change that. And basically the controller manager obtains the metrics from either the resource metrics API, which was mentioned before, or the custom metrics API, meaning that you can provide your own custom metrics. And based on that information, we can establish our rules, our thresholds, and there you go. And just going a little bit deeper, now that we have the metrics, like how does HPA defines that we need more or less replicas, right? All we're saying is that, hey, here's my CPU consumption. If it's 50%, do something about it. So how does it do under the hood? So as an example here, we have as a current metric 200 millicores, and the desired value is 100 millicores, okay? So the number of replicas will be doubled in this case because 200 divided by 100 is 2, right? So imagine that current metrics here will be 200 and the desired metric is 100. So we're consuming 200 millicores, but we want to consume 100 millicores. If we divide those numbers, we're going to have 2, and then we have our current number of replicas. So the current number of replicas we have, let's say we have 1 replica. That 1 will multiply by 2, and that's going to be our desired number of replicas. That way, we're spawning more replicas in order to take care of this specific use case. So yeah, let's keep moving forward. And there goes the HPA, and now we're going to start talking about the custom pod autoscaler. So what is the custom pod autoscaler anyways? So the custom pod autoscaler is a framework, it's an open source framework developed by some folks, if I'm not mistaken, in Ireland. And they developed this framework mostly because there's some faults on the HPA. Not some faults, but there's some parts of the HPA that are not the most flexible. One of those, and you probably noticed that already, is the fact that our equation here is hard-coded. So HPA only works with this equation here. Obviously, you can switch metrics, but you cannot switch the equation. So it is a hard-coded algorithm. So because of that, we can change metrics, but we cannot change the model itself. So what if we want to test other autoscaler strategies? We're stuck with this one here, right? If we want to use something different, HPA is not going to be our best friend. So how can we fix this, right? We want something that enables us to write our own scaling logic. And that's where the custom pod autoscaler comes to play. It literally lets us write our own Python scripts in order to define our models, okay? So let's keep moving forward. So it's important to notice that the custom pod autoscaler itself, again, it's an open source framework that already existed. It was not created by me or Pedro. We developed on top of this framework in order to create our platform. So this comes from the author itself, and I think it's good to point out the crux of the issue here is that for game servers, it doesn't make sense to scale on CPU load or memory usage. And even if you implemented custom metrics, the scaling algorithm wouldn't scale with this in a sensible way. The game servers should scale on number of players on the server or number of players looking to join a server, trying to ensure there are always positions available. So again, that's a very good use case where, again, it doesn't matter if you have the metric there, the equation itself, the algorithm that comes with HPA does not fulfill this use case. So we need to do something that is there's more flexible for the use case of a game server, for instance. So how does the custom pod autoscaler work? So let's say I want to make my custom pod autoscaler today. How does it work? Well, it's pretty simple. The framework deploys 2 things. It has an operator, and it also has a second part, which is the actual CPA. So let's just jump step by step here. The first thing you need to deploy in your cluster is something called the custom pod autoscaler operator. And we're going to see that in a second. We're going to have a demo of the custom pod autoscaler. After you deploy the operator, then you can deploy your CPAs. So the CPAs are going to be similar to the HPAs. So for each deployment in the cluster, we're going to have a CPA. The same way that before for each deployment we had an HPA, right? So how do you even create a CPA, right? So, and what is a CPA anyways? So the CPA is basically, you can view that basically as two scripts. The first script will be a metric gathering script. This script is responsible for collecting or generating metrics. Can be calling the metrics API, running calculations locally, or making HTTP requests. So for example, we can use this metric gathering function to call Prometheus and get information about our cluster. Or we can even call the metrics API from Kubernetes and get more information. Or we can use some other information that comes from a third-party database in order to define some specific metric, right? So that's what the metric gathering step does. It collects all those things, it queries those resources, collects that data, and then it passes this data as part of the return statement of the function. As soon as the metric gathering function returns those values, then we have the second function, which is the evaluating metric function. And those functions will gather the metrics that came from the metric gathering function. They will receive this blob of data, and based on that, we can just code our own algorithm, and that algorithm will basically tell if we can basically return to the custom pod autoscaler the number of replicas we want. So that's really cool. So basically we get the metrics as part of a blob, like a dictionary. We look into the metrics, we make our own algorithm, our own model, our own strategy, and that strategy will then need to output the number of desired pods that I want to scale for that specific deployment, the number of pods that I want for that specific deployment. So should I scale down? Should I scale up? That's basically all going to be done in this step here, all that logic. So now it's time to check the code and deep dive into it. Let's do that. Do a quick demo of the custom pod autoscaler. Again, this is an open source project. You can find more information at custom-pod-autoscaler.readthedocs.io. The documentation is actually pretty good. The first step in order to have the custom pod autoscaler running in your cluster, in order to deploy CPAs actually, and start monitoring your deployments, is to deploy the custom pod autoscaler operator. So in order to do that, we're going to declare this global environment variable here version, and then we're going to do a kubectl apply, and we're going to get the file directly from GitHub, passing the version environment variable that we just declared. And now, if I do a kubectl get pods, now I have the operator running on my default namespace. That's great. So what is the next step now? Well, this project is actually, again, quite complete, and they have an examples folder. Inside of the examples folder, one of my favorite examples is actually the Autoscaler code base. And it actually shows exactly like how this works, like how to deploy your CPA. So inside of the Autoscaler folder, we have a deployment.yaml file, and this deploys a very simple service that uses this hello Kubernetes image here, and it runs on port 8080. So it's a very simple hello Kubernetes application, and it's running on 3 replicas. You can also notice that on the metadata here, we're passing the values labels, and we're passing labels, and then number of pods 0. So we're just passing some extra metadata, just be aware of that. So the first step we're going to have to do here is to deploy this. So we need to deploy a service in order to monitor the service, right? And right now, right now we don't have any service in our cluster. So let's just do that. So kubectl, and then we're going to do apply -f and deployments. And there we go. We created the deployment, so now we should be able to get pods. And soon enough, again, the deployment was specified 3 replicas, so we have 3 pods being generated here, and one of them is already running. And there we go. Everything is running now. So now we have a service running. Great. Now I want to monitor that service, right? So now that's where the CPA starts shining. Now we're going to see how it actually works. So for the CPA, we have a Docker file here, which actually explains a lot how this works. So this Docker file basically uses like a base image developed by the folks that made the custom autoscaler. And the important part of this file is that we're supplying this Docker file a config YAML file, an evaluate.py function, and a metric.py function. So just a refresher, metric.py is responsible for getting the metrics from HTTP endpoints, databases, whatever, and evaluate will get those metrics collected by the metric.py function, and we'll make a decision if we're going to scale, we're going to get more pods or less pods in our cluster for that specific deployment. And we have config.yaml where we're going to have some configuration done. So let's start with config.yaml there. So config.yaml basically contains some interesting information. It tells us that we have an evaluate function. It's of the type shell. The function should have a timeout of 2.5 seconds. And the entry point of the function is Python, so it's a Python script. And the command is evaluate.py, which is the exact file that we pushed to the container, right? The second thing it also establishes is the metric function. It's also a shell function, has a timeout of 2.5 as well. It's a Python script, and it's called metrics.py. We also established the minimum number of replicas, and there's a very cool thing here we can configure. We can establish the custom pod autoscaler to run per resource, which means it's going to run per deployment, or we can even run it per pod, which is going to run like per each specific pod inside of a deployment, or each specific pod inside of the cluster itself, right? So this is the config file here. It basically tells us which are the entry points for our evaluation and metric. So besides doing pure scripts, we could also call endpoints here. We can call different languages. Obviously, the Docker image that we're using already has Python installed, and already has a bunch of tooling that's why we basically had to just supply the files inside the Docker image. But if you check the other examples, some other examples, just use the Ubuntu image or something else. Anyways, so now that we know, now that we understand config and the Docker file, let's jump into the metric.py function. So the metric.py in this case here, it's very simple. Again, we're going to be monitoring per resource, and the resource here is of the type of deployment in this case. So that's pretty much like a simple data we're going to, this is pretty much like some simple data we're going to be getting whenever this function gets executed. So this function will get the simple data, convert the JSON information, and then it will get the metadata here in this case, so resource metadata. And inside of the metadata, it's going to look for labels. And inside of labels, it's going to look for a number of pods, and it's going to return that as our metric. So it's a pretty simple metric gatherer, right? Like it's not going to Prometheus or anything complex like that. It's just looking for metadata in our deployment and returning that information. And as soon as it returns that information, it goes to the evaluate function. And the evaluate function then captures this information as part of the metrics array. So we have here resource hello Kubernetes. The value is 3, which is exactly the value we just passed in the number of pods. We also have access to the resource information here. And based on that, we can make a decision. So we're capturing the value from metrics, position 0, value, so 3. And based on this value here, we're passing this value to the target replicas. So this is a pretty simple custom pod autoscaler. We're basically saying the label that we put in our deployment, so the number of pods, will be the one responsible for scaling over here. So we declare that number of pods is 3, then that value is being constantly captured, and we're going to make sure that the target, we have 3 target replicates always. And again, this is a very like redundant like custom autoscaler, but it's just to get the idea. Finally, we have and then finally we have the CPA file. So far we deployed a service. We understood how to get our Docker image going for the CPA, but let's take a look at a simple CPA YAML file. So the CPA YAML is it basically generates a resource deployment with it generates a resource of a type custom pod autoscaler, and this resource has a name ZeroScaler, and basically it's going to be using this image called ZeroScaler with the tag latest. and then we define which deployment we're going to be tracking, right? So in this case here, we're going to be tracking a deployment called Hello Kubernetes, which is exactly here. Oh, sorry, it's here in our cluster, right? So Hello Kubernetes is over here. If I do a get deployments, we should see there like Hello Kubernetes. So that's it, pretty simple, right? So let's do step one first. Right now, the zero scalar image is not available, so we need to make our own zero scalar image. So let's do that. So in order to do that, we're going to open this really quick, and we're going to do Docker build. We're going to tag this Daniel Mapar zero scalar, and we're going to be building the Docker image in this directory. There we go. And then we're going to be doing Docker push Daniel Mapar dash zero scalar. And I'm already connected to Docker Hub, so this is basically pushing the image to Docker Hub. Now we can literally just take a look. Let's just do it. Open a new editor here really quick. And then we're going to change this guy to use the dmapar or the Daniel Mapar. I think that's the name I gave it to it. Oh, yep. So the Daniel Mapar image. And let's open our terminal once again here. And we can just do kubectl deploy f, oh sorry, apply f CPA. And boom. Okay, it's creating our CPA now. Let's do a get pods here. It's creating the container. So it's called zero scalar. So it's going to be monitoring our Hello Kubernetes service, and it's running. So let's do a kubectl logs f, and let's just log CPA here. Oh, sorry, logs f, and let's log zero scalar. And there we go. So rescaling from 3 to 0 replicas. So no changes in target replicas. So that's it. Our CPA is running, and it's rescaling our cluster right now. It's pretty neat. So that's how the CPA works. Okay, now that we understand the code, let's take a look at next steps. So now that we understand the custom pod autoscaler framework, let's understand why we wanted to develop a platform. So the custom pod autoscaler platform just works on top of the framework. And the reason why we developed this is because me and Pedro, we were like writing our own autoscaler functions, and we noticed that the process was pretty tedious. Every single time we were changing our evaluate function, we had to change it, evaluate.py, rebuild the Docker file, redeploy it to Kubernetes, and that process was super repetitive. We wanted something more flexible. And the reason why we made this platform is because the CPA, the custom pod autoscaler framework, does not cover load testing. So we wanted a solution that could also trigger load testing for us, so we wouldn't need to go to the Jupyter Notebook and do that. Okay, so that was the main motivation there. Let's take a look at this design diagram. So on the left side, we have our deployments here. So the product catalog service, checkout service, front end, those are some sample services we have in the cluster. On the center here, we have our CPAs, our custom pod autoscalers. And again, it's a one-to-one relationship with a deployment. So let's say we have a product catalog service deployment that will have a CPA attached to it. But the thing is, this CPA here has some generic code. So instead of making one CPA for the product catalog service and another one for the checkout service, we're going to make a generic CPA with a generic metric and evaluate code that can be used by all of them. And how do we do that? So the metric part is pretty simple. We just go to Prometheus and we get a lot of metrics about CPU consumption. And we're going to see that in a demo in a second. The coolest part here is not the metric part. The metric part, we're just going to Prometheus and getting CPU consumption for the deployment. The cool part here is the evaluate part. So the evaluate part actually does something really tricky. So instead of us providing the actual evaluate function, we developed a front end where a user types, like he codes his own evaluate function, and submits that function. So the way it works is we have a CPA front end. The CPA front end will provide a text box where the user will write their custom pod autoscaler function. That function will then be passed to an API, and the API will save that function, that code, inside Mongo. Then, whenever the CPA checkout service, let's say the CPA metric evaluate function is starts running, that function will go to Mongo and get the code that it needs to execute. So it's much more flexible in that sense. So basically, right now, the front end will be able to will let us save functions in real time. And not only that, but it also enables us to trigger load testing. So on the front end, I can click load test. That calls the API. The API calls locust, and that will do all the load testing for me. So this is a very powerful platform. It made our lives much easier in order to do all the data collection. And finally, as soon as the data is collected, everything is going to go to MongoDB, and that data can then be queried using Jupyter Notebook. So let's do a demo of it. Let's see how it works. Okay, so let's see how it works. So we created a fork of the EECS6446 project repo, and here it contains all the instructions on how to run the custom pod autoscaler platform. So let's just do this step by step. So first things first, let's take a look at our cluster. And right now we don't have any service deployed. So I'm going to navigate to Files, and I will actually deploy the boutique. So here I'm going to do an apply. I'm going to deploy the boutique microservices. And there you go. Meanwhile, as those services are being deployed, I'm actually going to just follow the tutorial here. So in order to deploy this, the first thing we need to do is install MongoDB. So we're going to just use Helm for that. To install that shard. There you go. The repo is added. We're going to install Mongo. And there you go. It's installed that fast. Now we can just, one of the things that we want to do is definitely port forward, like, so Mongo is running on port 27017. We're going to just forward that port so we can access Mongo in our host machine here. Oh yeah, well, I gotta just wait for the pod. It's still running. So kubectl get pods, and Mongo is still provisioning there. Should be done in a second. There you go. So now I can literally just forward the port, and there we go. And the next step is install the Mongo client. I already have it installed in my machine, but you can install it in yours. And then we're going to export the Mongo root password to this environment variable here really quick. We can do an echo on that, and we should be able to see it. There you go. This is my password now. Let me take a note of that. And finally, if I want to get inside my Mongo instance, I can literally just do Mongo, and there you go. I can see all my databases and everything. So okay, we have Mongo running, and we know our password, which is great. So I'm going to leave my password over here for now. Now moving forward to the API. So for the API, the first thing we need to do is set up API some credentials for Kubernetes. And the reason for that is that we're going to be using Kubernetes API, the Python Kubernetes package, or actually the Kubernetes API inside of the pods instead of outside. So we need to give role permission for those pods. Because this is a test environment, I basically gave admin role permissions for pretty much all the pods. So let's deploy the API. So we're going to just navigate to the API folder. And it's pretty simple. We just need to do an apply API, but before doing that, we are going to open API, and we're going to do some changes. So the only change we're going to do is actually just the password. If you want to run that locally, also as part of the README, it's important to change any environment variable that is different. So in this case here for me it's only the password, but obviously as you're running in a separate cluster, in a different cluster with a different IP, also change the IP for your low-cost API and also for your Prometheus API. And there you go, that's all the changes we need to do here. And we can do a kube apply. So let's come back. And let's do a get pods to see if it's working properly. And it is. We have an API, and we can even see if it's just working. So kubectl logs f. And there we go. The API is running. It's running on port 5001, being served on 5001. So we should be able to just go to 5001. And yeah, there's nothing on the main route. I also left, I believe I left some Postman file inside of this folder. So in case you're using Postman, you can literally just open it. You can click CPA, and here you have all the endpoints for this API. So let's just try one of the endpoints, the get predictions endpoint. And there we go, it's returning nothing because there's no predictions. We can also take a look for load tests. There's no load tests. And let's take a look at deployments. No deployments. Okay, that's good. The API is running. We should be able to see all the requests here. That's great. Now let's deploy the last part of the system, which is, oh yeah, we still need to deploy the front end. So let's deploy the front end first. So cd front end, and also same thing, just deploying the front end. Let's open the front end folder. Let's check the YAML file. Over here, because I'm using on my cluster IP, I don't need to change the IP, but this is the IP for my for the API that I've just shown on Postman, the one that we just deployed. Obviously, for your deployment, the IP will be different. And there we go. So let's just run this guy here. There you go. It's created. And then finally, we are going to deploy the actual pod autoscaler. So we're going to just deploy the operator at first. So let's declare this variable. Let's deploy the operator. There we go. And if we do a get pods here, we should see that everything is running properly actually. Everything is running properly, and yep, that's good. And okay, now we have the operator running. Now we just need to run our CPA, right? So let's open our CPA actually, and let's apply it as well. Same step for the CPA. Let's take a look at the YAML file. The only thing here is the password, so the password changed. Let's take this new password here, and let's paste it over here. Again, Prometheus, check the URLs there. For Mongo, like it's pretty much standard ports, the database name, no changes are needed. It's just the password and the URLs, the IPs that needs to be changed. And in this case here, we're going to deploy a CPA only for the card service. So this CPA here will be following the card service deployment, okay? And let's do that right now. So let's come back here and do a CPA apply. And there we go. And now we should be able to get pods. And we should be rolling in a second there. Okay, actually we can even do CPA service here. So kubectl logs f, and there we go. Our autoscaler is running now, and let's take a look at our front end. So we have a front end for this project. It's running on 3001, and that's it. It's very simple front end. So what is this front end, right? Let's understand how it works. So the first thing here, we have a list of deployments that we want to follow, right? So this autoscaler function will run only for the deployments that we list over here. Right now, we have no deployments. We need to add at least one, right? So let's add one deployment. So In our case here, we made a CPA for the cart service deployment, so we can go over there. So right now the CPA is complaining there's no deployment not inside the list, so there's no deployments yet. So let's take a look at this guy. We're going to add the cart service here. Okay, and then if we refresh, that's there. And if we go to Postman and we go to get deployments, we also see that cart service is part of one of the deployments now. The second thing now is my function, right? And that's some pretty cool stuff. I can create whatever function I want to scale my service. So right now this is the default function. Let me just click save. The function is saved over there, but I can call whatever function I want, right? So right now the function is pretty straightforward. Like right now this function gets the last prediction, the CPU data, and the current number of replicas for the deployment. So for this deployment here, for cart service, we're going to get the number of replicas, the CPU data. It's basically a dictionary that contains the CPU average consumption percentage. So what's the percentage being consumed for this deployment in terms of CPU based on the limits that were established on the deployment. And finally, the last prediction. So the last prediction is, okay, the last prediction is actually whatever I return over here on the CPU, on this side of the return, okay? So the return is the desired number of replicas. So the first position is going to be the desired number of replicas that I want for this deployment. And the second position is my data, so my prediction. And this will be returned here and inject back into the loop as the last prediction. Okay, so let's take a look at the logs here really quick. And okay, there we go, it's working. No changes in the replica, no changes in the replica. Now let's do a load test, right? So we created this magic button here called trigger load test. So trigger load test will basically call locust for us, and we'll start triggering a load test. So let's do that. And right now, if we go to get predictions, we're going to be able to see, so get predictions it's the database table that collects all the predictions being returned over here. So everything that is being returned by this function is collected here. So as you guys can see, we have the cart service with a CPU average consumption of less than 1%. The millicores, this is the number of millicores being used. This is the limit, CPU limit for this guy, and this is the number of replicas, okay? So this information is being pushed back every single time. And here, in this case of this autoscaler here, we're not using the last prediction for anything. We're just passing the CPU data. So anyways, let's trigger a load test and let's see what happens. So actually, before doing that, I have no load tests. I'm going to click trigger load test. And there we go. Now I have a load test. And it's in my database, and the status is running. We know the exact equation that this load test is running with, the timestamp, and which deployments are running this autoscaler, this function. And so far we have no data from the load testing. As soon as it finishes, we're going to have some data. And let's take a look at this here. So as we can see, our CPA is still running. And if we keep calling the get predictions endpoint, we're going to see that our CPU average should start increasing soon because of the load testing. And right now, the way this works, the load testing is fixed. So, oh, there you go. The CPU is increasing slowly, but it is increasing. And so right now, when we click that button, what's actually happening under the hood is we can open API here, app, and it is basically triggering locust over here with this sequence of requests. So for future versions, definitely we want to make this configurable, but for now, whenever you click that, you get this sequence of tests being triggered into the deployment. Okay, so let's do this one more time. And obviously this will take a while, so we just need to wait. But as we can see, the CPU is already spiking. So I'm gonna pause now and I'll come back as soon as it's done. Okay, so the load test ran successfully. We can take a look at get load test over here, and we can go to JSON mode, and we can get the ID of the load test. And as we can see, the status changed to done, and we have all the data aggregated over here. Now we can just jump back to Visual Studio Code, and we developed a Jupyter Notebook where you can basically specify your database password and information, and here you can specify your ID. So let's get a hold of the password now. I think the password was right here. There we go. So we're going to change that. And now we should be able to plot our results. So let's just run our thing here really quick. Okay. Repeat disable. Okay, and now we're going to plot it. And we're going to plot this as well. And there we have it. So for this experiment in particular, there was no actual pod scaling actually over here. No pod scaling at all. But yeah, but we can catch all the values here, the average response, the number of users, everything is here coming from the database. And yeah, so this seems like our load balancer had like a bit of a higher threshold, so no scaling was actually done over there, no upscaling. Okay, so that's it for the demo. Okay, so now that we finished the demo, thanks for watching. For more information and for a step-by-step code that can be followed, just check this link on GitHub, and thank you.